Okay.
No, I don't.
So at the top there,
No.
okay. So at the top here, we have bullets of things you guys were supposed to get out of this chapters 3 and 4 and to know. So we call those objectives. These are the things you should know a little bit about, or quite a bit about. And the first one, when we have tests in the past, students do poorer on this section because they can't differentiate between the different groups and the different parts of the periodic table. So just study that one sheet I gave you where you guys had to take notes on the different groups and different areas of the periodic table and know where elements are located. And if I give you an element, you'll know if it's in a certain family or in a certain section of the periodic table. Questions on that? Know the different properties of metals, nonmetals, and metalloids. And so what that means is that when you guys did the lab, which I did grade, it was like 25 points. Some of you might want to come in and talk to me about that because I had some things on there that was incomplete because you didn't do it the way I wanted it done. And I want you to get the points and not have a bunch of points subtracted. So come and talk to me if that's on your Infinite Campus, and I'll give it back to you, and then you can.
For which one?
It's the lab that we did. I just graded it. Okay, there's about 4 or 5 people in here that misunderstood how they were supposed to do it. Okay, but metals are properties that would be that they're a lot of them. Well, they have a luster. They reflect light. They are malleable, ductile. They conduct electricity really well. And so those are some properties that metals have. Non-metals are usually they don't reflect light, so we call them dull. They don't conduct electricity, okay, or heat. And then metalloids is kind of a combination of both. They will be kind of conductors of electricity, but they also have properties of non-metals too. So there should be 4 essential parts of Dalton's atomic theory. And basically he just said that all matter is made up of atoms, and that the atoms of the same element are really similar except for what? Except for their mass because of isotopes, because they have different number of neutrons in them. But everything else is the same. That when they go together with other elements, they only go together in a set ratio. So we know that set ratio. And when they do react, they'll kind of come apart. The atoms come apart, rearrange into something totally different than the original substances. Thomson's experiment is the one on that is found the electron because the pathway of the cathode ray was deflected away from a negative charge but attracted to a positive charge, so it showed it had a negative charge. It also moved that Ferris wheel, or little wheel, showed it had mass. And it also showed that if the matter is made up of these particles called electrons that are negative, there must be something counteracting that. That has to be, later on, that was found by Rutherford. He found that the nucleus was extremely small, atoms mostly empty, that nucleus is, found the proton was positively charged as well. Next thing, the subatomic particles and their positions. That's why I gave you notes on protons, neutrons, and electrons and their differences. You should have that. Understand what an isotope is, that it's an atom of the same element with different number of neutrons or different mass number. This is the chart. Determine the atomic number, mass number, neutrons, protons, electrons, and charge. And then the last one is how to figure out the average with percentages involved. Okay. So we'll specifically go through the answers. I just want to tell you that you could have a different essay question than previous classes. I know information gets shared between classes, and you're the 4th period class. And there's the 2 periods before you, and mainly 1st period. So that information tends to get out there. So you probably have a different essay questions than they have. All right? So just for your information, if you're getting information from somebody, it's going to be different. Questions you guys have. We'll just run through this. So you'll have a chart like this, probably about 10 points of the test out about, probably about 12 or 13 points total out of about 65, 70. So it's about a fifth of the test would be this. So you get a lot of your information from here. So this 34 here is going to move on me. Why are you moving on me? Oh, no wonder. I got the arrow. Now it won't move. Okay, 34 is this number here. 79 is the mass number. All right? And so the minus 2 here means there's 2 more electrons than protons, so that would be 36. And then the neutron's the difference between the 2 numbers, so that would be 45. Any questions you have on that? Okay. Next one is element 35. So look on the periodic table. I find element 35, and it's bromine. The electrons is 36, so that would be a minus 1. The difference between 35 and 80, so I minus 35 here, because that's protons. I get 45. So that is neutrons. And then so if I put in my numbers, I should have 80 up here, and then down below I would have 35. Questions? Okay. The next one, silver, 47 is that bottom number. 108 is the mass number. The difference between those two would be my number of neutrons. So that would be 61 neutrons. And there's no charge, so it has to be the same. Electrons and protons. 26, 57. I always like doing the ones I know. If I know for sure, and then anything I have to calculate, then I can kind of go off of that. So 57 minus 26 would be the neutrons, so that would be 31. And then the electrons, it's a plus 2. So that means I've got 2 fewer electrons, so that should be 24. And the last one, element 76, is osmium. And that would be, when I add these two together, I get the neutron, or the mass number. So that would be 190. I'm going to say the protons and electrons are the same if that's my choice. Sometimes I can't do that. So that would be osmium 190. Or you could have OS with 190 and then 76 down below. Yes?
So when it comes to this, we're not going to have to do anything with the atomic weight, though?
You will on question number 2 here. What is the atomic mass of vanadium? So when you look at vanadium, then that would get you your atomic mass. So that would be 50.9415.
Will you have to like round up?
So here's the deal. Some of you guys round up, and when you round up, it looks like that's the mass number. That's not the mass number we're looking for. Okay? Some of you are thinking this mass number is the rounding of the elements, their averages, the atomic weight on the periodic table. That's not the case. It's close. Those are specific isotopes. When you look at on the periodic table, that's the average of all the isotopes. So when you do that, that's what you're going to get. So vanadium, on that one, that would be 50.9415.
Just write the full number out.
Yep.
Okay.
You want? Yep. Because that's what the students were not doing on one of the worksheets.
And then there's also a mass number?
The mass number is the number of protons and neutrons. So this is taking into account all the isotopes. It'd be like question number 4 on the back, what you're doing on the review. So atomic number for radon, that's 86. And then phosphorus. Phosphorus is element 15, has a -3 charge, so it's 18 electrons. I feel pretty confident on these. I mean, every year we do them, we go through enough examples. Most students will get those all right. What students will do, they'll mess a column up. They'll get neutrons and electrons mixed up, or protons or neutrons and mass number mixed up, and so they'll miss all those questions in that column. So hopefully you don't do that. So that's a big mistake when you do that. So just double check the columns when you do it. Do you turn over the back? Okay, on this one, these are percentages. They'll add up to 100%. So 100% of the weight is the averages of all these when you multiply it by their percentage. So this would be divided by 100, so it'd be 0.0242. This is 0.0659, 785. And then you multiply those out, and then you're going to add them all up at the end, and then that's going to be, when you add them all up, that's your average atomic weight for barium. And it should come out really close to barium's weight on the periodic table. So when I multiply these out, these are the numbers I did get. And this one, you might double check if you come up with an answer that is different than what's on the periodic table, or a lot different than what's on the periodic table. Because you know, if that's the case, then you're going to be way off from what that answer is supposed to be. So that's supposed to be 137.05 is what I came up with. I just rounded.
What's the label on that?
It's AMUs, atomic mass units. They are. Questions on that?
What is atomic mass?
Well, what it is, it's just a relative mass compared to everything else. So it gives you
Atomic mass unit, I mean.
atomic mass unit.
Yeah.
Okay, atomic mass unit is like if something weighs. What they do is they base it off of what's carbon-12, and they say carbon-12 is exactly 12 AMU units. Okay, so then everything else related to carbon-12. So if something has double the mass of carbon-12, okay, what would be its atomic mass units? It'd be double it, wouldn't it?
24?
It'd be 24, right? So that's how they come up with this thing called relative atomic mass. Because the mass of an individual isotope is too small to measure, so they compare masses. When they originally started doing these, and when they compared the masses, they said this is a relative mass of carbon-12. It's 12 AMU. We're going to compare everything to carbon-12.
Why carbon-12?
They just had to have a standard, kind of like a meter stick. Why is the meter stick that length? Because they set that as a standard. So a lot of times you have standards that are set, that are logical, and then everything's based upon that standard. Okay? Questions on that? All right. So we get to this part where we have to differentiate between the physical properties and chemical properties. Okay, and chemical changes. So if it's a change, something has went through a process of now it doesn't look the same as it did before. If it's a property, it's a measurement of some measurement that describes the characteristic of the substance, or it's a word or meaning of words that represents if it does do something, then it's going to be a new product afterwards. Okay, so copper is a good conductor. What would that be? Physical? Be a physical. Because if I touch copper and test its conductivity, does copper metal change when I do that?
No.
No. Well, if it doesn't change, it's a physical property. Okay. Water's boiling point is 100. It's a statement about water and when it starts to bubble.
Chemical property.
No, boiling is a process that is going from a liquid to a gas. If it goes from liquid to a gas and it's describing where that happens, that's a physical property. Okay? The methanol burned and gave off a hot bluish flame.
Chemical changed.
It changed. It's now something different. You have to relate to your lab that you did, and you actually did that. Or something similar to that. So that's a chemical change. It changed. When it gives off a strong odor, what's it doing? It's evaporating. So it's just gone from a liquid to a gas.
Physical property.
I would accept either physical property or physical change because I mean the way that's stated, it could be giving off a strong odor right now. So that one was either one's fine. Okay, alkali metals are reactive with water.
Chemical property.
It's a property. Nothing's taken place. It just said if you put those two together, you're going to get explosions. Okay, it's going to heat up. Copper had a reddish brown color. It's just describing it, physical property. Okay, and then salt dissolved.
Physical change.
Just right. It's just mixing, so it's a physical change. Okay. Right. You're just kind of separating out the particles. When you do that, I gave you guys a chart that kind of goes through words that describe physical and chemical. If you guys remember that. I would look at that tonight, you know, if you get a chance, and it allowed you guys to do the little lab write-up when you had to do that. So it's just a little sheet that has changes right here, and it shows what up above, what kind of things are physical and what types of things are chemical right on that sheet. Okay, and then down below, observations you make. Yellow precipitate was formed. That means it's past. So it's got to be a change. And so precipitate is a solid left over. It's on that sheet. So that's chemical change. Dry ice disappeared into the air after several hours. So it's going from a solid to a gas. That's sublimation. So that's a physical change. The density describes how compact it is. Nothing's changing. So it's a physical property. And then metals usually have a higher melting point. That's just describing its nature, that they have to heat up pretty high before they'll melt. Physical property. Okay? Alright, so if it presently is doing something or it's in the past, it's a change. If it's a measurement or it describes something that can change but doesn't, and that's a property. Okay. You have to describe element compound, and if it's a mixture, what kind of mixture it is. Sodium metal is Na. That's an element. Glucose. We know that is C6H12O6 from biology, and so that's a compound. Kool-Aid was our example. You can't tell the different parts. You can't pick them out. It's a homogeneous mixture because we know it's a mixture of things. Bronze, brass, and steel, they're all alloys. And all alloys are just mixtures of metal. And they are homogeneous mixtures because you can't tell one from the other. One atom from the other in the mixture. They blend together. Sodium chloride is NaCl. So that's a compound. Two elements hooked together, two different ones. Carbon dioxide is two different elements hooked together, so that's a compound. Salt water is H2O plus NaCl. So there's no chemical reaction, they're just mixing. And so that would be a homogeneous mixture. You can't tell one from the other. Gatorade's a homogeneous mixture. And then tap water is homogeneous mixture. I didn't have heterogeneous on there. Probably would have been nice to have one on there. But questions on those? fit metal, non-metal, metalloid. So this is a metal, sodium's on the left side, chlorine's on the right side, that's a non-metal. Silicon's in between, metalloid. Iron is in the middle section, it's a transition element, so that's a metal. Neon is farthest to the right, going to be a non-metal. And aluminum is going to be a metal. That's one that sometimes people think is a metalloid, but it's over there by the metal section. Any questions you guys have?